Ever thought an image model could handle real-world physics, complex visuals, and even maths that go beyond basic formulas like integral x squared dx? Google's new Nano Banana 2 is surprising everyone by doing exactly that. And many people are wondering if this is the first tiny step toward AGI-level reasoning. Let's explore why this playful-sounding model is causing such a massive buzz in the tech world. The story begins with the first Nano Banana, Google's early visual model known for high-quality edits, transformations, and realistic rendering. It quietly entered testing under a hidden internal name, but users online quickly noticed how powerful it was and made it go viral. The community jokingly called it Nano Banana, and the nickname spread so widely that Google ended up keeping it officially. A few months later, the upgraded Nano Banana 2 arrived, and this version created a stunning leap in abilities. Viewers often ask how much an image model can really evolve between versions. The simple answer is that the jump was far bigger than anyone expected. Why does it feel like AGI? Most modern AI tools excel in only one area. Some generate text, others analyze data, and some create visuals. But AGI means the ability to understand everything together. Nano Banana 2 is not AGI, but it begins showing early hints of multi-step reasoning, real-world logic, and intelligent decision-making beyond patterns. It understands rules instead of merely copying images, which is why many experts say it feels like the start of something bigger. These behaviors resemble the building blocks of general intelligence, even if still in a limited form. Because of this, more researchers believe visual reasoning may be a major missing link in future AGI systems. To understand the hype, let's break down its most shocking abilities. A quick question for you guys. If an AI can reason across multiple domains, do you think that qualifies as early-stage AGI or still just advanced pattern recognition? Comment your thoughts below. Older image models struggled with physics. Objects floated, teleported, or ignored gravity entirely, turning simple animations into strange glitches. Nano Banana 2 changes this by predicting gravity, momentum, bounce angles, and curved motion paths with surprising accuracy. When asked to visualize a falling object, it follows real-world physics the way a human would. This means the model is not just drawing shapes, but understanding movement, collisions, and cause and effect. It feels like there's a tiny physics engine running inside its neural network. And that leads to the big question. What happens when future AIs apply this logic to real-world decision-making? Now answer this. If you dropped a ball from 5 meters high, what would hit the ground first? Your prediction or Nano Banana 2's prediction? Testers gave the model complex maths problems inside images, including integrals, trigonometric substitutions, diagrams, and symbolic equations. Nano Banana 2 didn't just read the symbols, it understood them, interpreted the structure of the problem, and produced the correct solution. This is extremely rare because mathematical reasoning requires logic, precision, and rule-based thinking. The model performs 3 difficult tasks simultaneously: reading equations visually, decoding their meaning, and solving them correctly. This fusion of maths and vision is a major breakthrough. It shows the model is moving beyond image generation into actual reasoning. Most image AIs fail when letters are broken, cut, or incomplete, either distorting them or guessing incorrectly. Nano Banana 2 instead analyzes the partial shapes with precision and predicts the missing structure intelligently. It reconstructs the entire word using context, probability, and visual understanding. The model blends linguistic knowledge with visual inference, almost like a human reading a damaged sign. Even when text is torn, smudged, blurred, or missing large chunks, it restores it with stunning accuracy. This ability goes far beyond simple pattern copying or pixel guessing. It shows that the model understands meaning, not just shapes. That shift is what makes this capability so remarkable. It represents a key ingredient in future AGI-like systems, and it proves that true intelligence can emerge even inside visual tasks.
Earlier image models struggled with moving objects in a scene.
Shadows broke, lighting shifted unnaturally, and shapes often warped. Nano Banana 2 shows far stronger spatial intelligence, keeping objects stable and consistent during rotation, resizing, or relocation. It understands how lighting should fall across surfaces, and how shadows naturally behave as objects move. The model also tracks perspective changes with surprising accuracy, maintaining environmental coherence. Most importantly, it preserves object identity, recognizing that the same cup remains the same cup from a new viewpoint. This is a major leap beyond simple image generation tricks. Such consistency requires an internal sense of structure and geometry. Very few visual models have demonstrated this kind of 3D awareness before. It hints that the system carries a deeper internal model of physical space. Nano Banana 2 doesn't generate an image instantly. Behind the scenes, it goes through a structured plan, draft, review, correct, finalize cycle. Instead of outputting a single guess, it checks for mistakes, revises details, and improves the results step by step. This mirrors how humans think when solving problems, making the output more stable, accurate, and deliberate. Self-correction is considered one of the biggest signs of higher reasoning in AI systems. Many viewers wonder whether this level of autonomy increases trust or makes the model feel a bit too human. Either way, it marks a major shift in how AI works internally. Beyond reasoning, Nano Banana 2 brings major technical boosts such as sharper resolutions up to 4K, cleaner edges, and far more stable detail. It supports multiple aspect ratios from 1:1 to cinematic 21:9, giving creators more flexibility for real projects. It handles infographics, diagrams, and charts with near-perfect clarity, avoiding the distortion issues older models had. Text accuracy is now extremely high, allowing professional-grade designs without manual fixing. Combined together, these upgrades make the model useful not just for experiments, but real-world creative and technical workflows. For many designers, this finally makes AI reliable enough to trust daily. AGI means understanding multiple domains at once, and while Nano Banana 2 isn't AGI, it shows early pillars of intelligence like physics prediction, math solving, and text reconstruction. It proves that reasoning can emerge through images, not just language. By late 2025, the model is publicly testable and likely built on Gemini 2.5 Flash, Gemini 3.0 Pro, or new Imagen tech, with internal teams calling it GemPix 2. Its abilities are expected to appear soon in Pixel devices, Google Photos, Workspace, and creative apps, setting a new standard for visual reasoning. Nano Banana 2 hints at future AI systems that combine physics, math, language, and perception into unified reasoning engines. If many AI models reach this level together, the world could see smarter robots, better assistants, automated engineering, and eventually something close to AGI. Google's Nano Banana 2 signals a major shift in how AI interprets the world, moving beyond pattern copying into real reasoning. Its ability to understand physics, mathematics, language structure, and spatial geometry shows how quickly visual intelligence is evolving. This model doesn't just generate, it thinks, evaluates, and improves its own work like a miniature reasoning engine. For many, it feels like an early glimpse into the foundations of AGI, showing how different forms of intelligence may merge someday. The world of AI is accelerating fast, and Nano Banana 2 stands as one of the clearest signs of what's coming next. We hope you enjoyed this video. If you did, don't forget to like, share, and subscribe to our channel.